Lesson: Understanding the role of scripting in AI integration. Understanding the role of scripting in AI integration is crucial for professionals aiming to harness the power of artificial intelligence in various domains. Scripting serves as the backbone for automating tasks, enabling seamless communication between AI models and applications. This lesson delves into the practical aspects of scripting in AI integration, emphasizing actionable insights and tools that professionals can implement to tackle real-world challenges. Scripting languages such as Python, JavaScript, and R are instrumental in AI development and integration. Python, in particular, has become the de facto language for AI due to its simplicity and the availability of extensive libraries like TensorFlow, PyTorch, and Scikit-learn. These libraries provide pre-built functions and models that allow developers to focus on solving domain-specific problems rather than reinventing the wheel. For instance, TensorFlow's Keras API simplifies the process of building neural networks, which can be integrated into applications to perform tasks such as image recognition or natural language processing. Effective AI integration requires the automation of data pipelines, model training, and deployment processes. Scripting facilitates this by enabling the creation of workflows that can be executed with minimal human intervention. Automation scripts can be written to pre-process data, train models, and evaluate their performance. For example, a data scientist can write a Python script that automates the extraction, transformation, and loading of data from multiple sources, ensuring that the data is cleaned and ready for model training. This not only saves time, but also reduces the likelihood of errors that can occur with manual data handling. Moreover, scripting plays a pivotal role in the deployment of AI models into production environments. Tools like Docker and Kubernetes, combined with scripting, allow for the containerization and orchestration of AI models, ensuring they are scalable and can handle varying loads. A practical example is using a Python script to create a Docker container that packages a trained model along with its dependencies. This container can then be deployed on a Kubernetes cluster, providing a robust and scalable solution for serving AI models in real-time applications. Scripting also enhances the integration of AI with other software systems. Application programming interfaces are often used to facilitate this integration, allowing different software components to communicate with each other. Scripting can automate API requests, enabling seamless data exchange between AI models and other applications. For instance, a script can be used to send data from a web application to an AI service via an API, receive the processed results, and display them to the user. This is particularly useful in scenarios where real-time data processing is required, such as in financial trading platforms or recommendation systems. Real-world case studies highlight the effectiveness of scripting in AI integration. Consider a healthcare startup that uses AI to analyze medical images for early detection of diseases. By leveraging Python scripts to automate data pre-processing, model training, and deployment, the startup reduced the time to market for its AI-powered diagnostic tool by 40%. Furthermore, scripting allowed the integration of the AI tool with existing electronic health record systems, facilitating seamless data flow and improving the efficiency of the diagnostic process. Scripting frameworks such as Apache Airflow and Luigi provide structured approaches to manage complex workflows involved in AI integration. Apache Airflow, for example, allows developers to define workflows as directed acyclic graphs using Python scripts. This framework automates the scheduling and execution of tasks, ensuring that data pipelines run efficiently and reliably. By using Airflow, an organization can manage its entire AI development lifecycle, from data extraction to model deployment, with improved transparency and control over the process. Additionally, scripting can enhance the interpretability and explainability of AI models, which is crucial for building trust with stakeholders. Scripts can be used to generate visualizations that provide insights into how AI models make decisions. Libraries such as Matplotlib and Seaborn in Python are invaluable for creating plots that illustrate the relationships between input features and model predictions. By presenting these visualizations, data scientists can communicate complex AI concepts to non-technical audiences, thereby fostering a better understanding and acceptance of AI solutions. Integrating AI into business processes also demands a focus on security and compliance, areas where scripting can be beneficial. Scripts can be developed to monitor AI systems for compliance with regulatory requirements, such as the General Data Protection Regulation. These scripts can automate the logging of data processing activities, ensuring that organizations maintain transparency and accountability in their AI operations. Furthermore, security scripts can be written to detect anomalies in AI model behavior, alerting administrators to potential threats or biases that could compromise the integrity of the system. The integration of AI into existing systems often encounters challenges related to data compatibility and system interoperability. Scripting can be instrumental in overcoming these challenges by transforming data into compatible formats and facilitating communication between disparate systems. For example, scripts can automate the conversion of data from proprietary formats used in legacy systems into open formats that AI models can process. This ensures a smooth transition and minimizes disruptions to business operations during AI implementation. In conclusion, scripting is a fundamental component of AI integration, offering practical solutions to automate processes, scale applications, and enhance system interoperability. By leveraging scripting languages and frameworks, professionals can streamline AI development and deployment, address real-world challenges, and improve the efficiency and reliability of AI systems. As AI continues to evolve, the role of scripting in its integration will become even more critical, necessitating a deep understanding of scripting techniques and tools among AI practitioners. The actionable insights and examples provided in this lesson equip professionals with the knowledge and skills needed to effectively integrate AI into their workflows, driving innovation and success in their respective fields.